To supply high-quality gasoline in the growing quantity required today, Standard Oil Company of California has to keep looking for new and better refining techniques, and as they are discovered, use them as efficiently as possible. A key process in helping to get a greater yield of gasoline from each barrel of crude is fluid catalytic cracking. This complex process requires scores of measurements, temperatures, pressures, flow rates, levels, and all these data are constantly changing. And as each changes, it affects the rest of the process. Keeping all this in balance is the job of the process control operators. They could use a better tool, and management took action. California Research Corporation, a subsidiary of Standard Oil Company of California, was investigating new ways, including computer application, to improve the process and give the operators fuller control. Later, with representatives from the IBM Corporation, they further explore the idea of using a computer system to help control the fluid cat cracker. Experts from both companies got together to examine the plant operating records from a typical period in the past. They found enough variation in the cat cracker's production output to make it economically worthwhile to find out if those past records could have been better with a computer control system. Preparations for a test run began. First, the computer would have to have a complete description of what the cat cracker could deliver under ideal conditions and how much it would cost. Next, the computer had to know everything that went on in the cat cracker, all conditions of temperature, pressure, feed quality, flows, levels, and how they related to each other. The computer also had to know the plant limits, like the top speed of a compressor involved in the process. All this information, along with the plant's past records, was transferred to punched cards and fed into the computer. Its calculations would show what gasoline production and profits could have been during the test period if the process had been operating under a computer control system. The results showed it was economically feasible to go a step further, to see what the computer could contribute to process control under actual operating conditions. It was decided to use a computer at Standard of California's San Francisco Computer Center, over 400 miles from the cat cracker, where it had been solving engineering and scientific problems. On the process site at El Segundo, a terminal block was set up to receive electric signals representing temperature readings. Air signals measuring flow rates were changed by a transducer into signals which could also be fed to the terminal block. These electrical signals, along with other data, were translated into digital computer code, then sent over telephone lines by IBM teleprocessing equipment to San Francisco, where they were received and punched out on cards. The computer evaluated all the data it received and made control recommendations, which were transmitted back to El Segundo. A complete operator guide was typed out. Not only the suggested settings, but also the indirect changes which those settings would cause. With this new tool, the operators could bring the process to optimum performance more quickly, and now they could hold it there. One of the next steps was to cut down the time it took between gathering the data and getting the computer recommendations back to the operators. This turnaround time was reduced by installing a new process control computer at El Segundo and by connecting it directly to the instruments in an open-loop system. Now the operators had a running account of both what was happening in the process and what the operator guide indicated should happen if optimum performance was to be maintained. The last refinement was to close the loop, to link the computer to the controls as well as the instruments, so the process would be adjusted instantly to the recommended settings. The operators still retain the option of open loop operation. But in practice, the operators find they can do a better job by closing the loop. The operator's console provides them two-way communication with the computer. Their requests bring fast replies, and any data they feed in is quickly confirmed on their console typewriter. The computer control system also helps the operators keep records for process analysis. Every 6 minutes, their data log typewriter gives them a record of selected readings for instant reference. Also, the process operator's console typewriter is a permanent source of operator guide and conversion figures. The two typewriters do their jobs during both open and closed loop operation. To get a complete record of all input and output data in the process, again, regardless of whether they have the loop open or closed, the operators can switch on their punch tape recorder. Today, the closed-loop computer control system is giving process control operators a tighter rein on the fluid cat-cracking process than ever before, helping them improve quality in gasoline and other byproducts at a lower unit cost while meeting optimized production quotas. This story of how engineering skill, creativeness, and ingenuity contributed to a successful search for improvement is just one of the reasons why the standard sign remains the sign of progress and of leadership in the petroleum industry.